Vital. Let me share my screen first. So on behalf of Option, I would like to say a warm welcome to you. Unfortunately, my presentation will be in English since my Turkish is not so good. But I hope you can understand what I'm wanting to bring in this presentation. So I'm working in the headquarters of Option, which is in Leuven in Belgium. It's in the center of Belgium, close to the Brussels airport. And what I want to say today is a bit an introduction about IoT in general, as an introduction to Meltem, who will talk more about our products that we are selling through Vital in Turkey. First, I want to start with explaining that the Internet of Things is something rather new, coming from the machine-to-machine communication in 1 decade ago. But IoT is part of the overall communication on this planet, where you have people talking to people, you have people talking to machines. For example, chatbots is an example of that. But you have also machines talking to machine, and that's Internet of Things. And the whole communication is called Internet of Everything. And you see that each of the segments in the Internet of Everything has a certain growth expectation in the coming years, where all communication methods are having a quite significant growth. But since the amount of smartphones, for example, in the people-to-people communication is limited to the amount of people, there will not be so much growth in that market anymore as compared to a number of things that you can still connect in this world. So it's expected that the Internet of Things will be the fastest growing sector in the overall communication of on this planet. So what is IoT used for? Actually, there are only two use cases where IoT makes a lot of sense. The first use case is to be able to save costs. So, and you can save costs by optimizing an existing process. Imagine, for example, that you have people who go to the warehouse every morning and check the temperature inside the warehouse and put it on a sheet of paper. That's an existing process that is used in many companies. But if you put a sensor in this warehouse, you can remotely read out the temperature every second if you want. That's an optimization of an existing process because you no longer need to send people on site and you have more information available. Another reason why IoT can be important for your company is to launch a new product or a new service. So an example is, suppose you are a company who is installing heating equipment in companies. This is a big investment for a company because they have to spend several thousands of euros to install a new heater. If you could instead equip this heater with a number of sensors so we can remotely find out what the condition is of your heater. Do you need maintenance or do you don't need maintenance? What is the level of fuel that you have available? Then you can sell this heater as a service and the customer pays a monthly fee for being able to lease this equipment from you. And since you know exactly what is going on with your equipment, you can also do a better follow-up and a better maintenance. So that's a new kind of business model that you can create using IoT. But IoT is a very complex environment. And that is because there are so many things on this world. You have cars, you have machines, you have buildings, you have meters. And in each of these different segments, you have also sub-segments. So in the houses, you have the private homes, you have the apartment buildings, you have the factories. So it is a very complex world to provide solutions for all of these different IoT segments. So the solution that is that needs to be offered needs to cope with all of these different connectivity requirements that you have for each of these objects. A building will communicate with BACnet, for example. A sensor will communicate with LoRa or Bluetooth. If you have a vehicle, it will communicate with a CAN bus. And so the difficulty of IoT is all these differences that you have in each of these different use cases. There are, of course, also standards, luckily. So, for example, the communication to the cloud is done with a number of standardized communication methods, like TCP/IP, like a REST API, like MQTT, WebSockets, FTP, UDP. All these things are well described and also supported by the CloudGate. So how do you cope with these differences for each application? What many companies are doing is they make specialized gateways for each segment. So you have specialist gateways for buildings, where they support meters and BACnet, for example. You have other gateways for vehicles, where you have a CAN bus interface, like there is a gateway in every vehicle that you buy on the market nowadays. And with this vehicle gateway, the car manufacturer can find out how your maintenance is going on for your car. Do you have to come in for replacing the oil? How many kilometers did you drive? But of course, this is a very intense solution for a distributor, because they have to put things in their warehouse for each of these different segments. So CloudGate will take a different approach to this issue, as you will see in the presentation from Melton. How does an IoT solution look like in general? So first of all, of course, you have the objects. And as you can see, the objects can be a very wide variety. It can be a greenhouse where you grow tomatoes, but it can also be a teller where you can get cash from the wall. And then you have a connectivity to this equipment. Sometimes the equipment goes directly to the cloud, but in many cases, there is a gateway in between, which learns the protocol or knows the protocol of the object and transforms into data that can be sent to the cloud. Because for a vehicle, it's not very obvious to send CAN data directly to the cloud, because CAN data runs at 1 megabit per second. That's an enormous amount of data. And you don't want to know everything from a vehicle. You also only want to know speed, acceleration, braking, all these things which are relevant for the backend application. Of course, the gateway has to communicate to the cloud, and typically you have a network that can be the Ethernet inside the building. It can be Wi-Fi, but very often it's also a 4G or a 3G communication network from the cellular provider like Turkcell or Vodafone in your country. Then you typically have a platform in the cloud that can be Microsoft Azure, it can be Cumulocity. There are a wide variety of networks or of cloud platforms on the markets. Managed Engine is sold by Vitel. That's also one of these platforms that can be used to store data in the cloud. And then, of course, the company who is deploying IoT wants to pull in this data in its own cloud system inside the company. And so you have systems like Exact, SAP, Oracle, who are providing the enterprise resource planning of a company, and they pull in certain data from this cloud platform for their own internal use case. And that's what the whole cycle of IoT is consisting of. So we are providing the connectivity between the thing and the cloud. So that's what CloudGate is doing. If you look at communication, wireless communication in general, you have several types of communication mechanisms. You can have a sensor communicating to a gateway. And this communication can be over LoRa, can be over Bluetooth, it can be Zigbee, it can be Wi-Fi. There are a large number of connectivity mechanisms. And the gateway is typically talking to the cloud over either Wi-Fi, if it's about wireless, or it will be a cellular communication technique like 2G, 3G, narrowband IoT, LTE. All these things are, let's say, cellular communication technologies. And you have also sensors nowadays who talk directly to the cloud. So they don't need a gateway in between. And narrowband IoT sensors are typically sensors that can communicate directly to the cloud without a gateway in the middle. So Option is now working on a portfolio, for example, of light controllers that can be put on lights in smart cities. And then these lights will talk with narrowband IoT directly to the platform. So there's no gateway in the middle that needs to be deployed. Other known techniques for direct communication to a cloud network are LoRa and Sigfox. In many countries, you have a nationwide LoRa network. In Turkey, you don't have this, but you can have still private LoRaWAN deployments like CloudGate is offering. Wireless communication on itself is also an art because There is a wide variety of communication techniques going from very short range. Your smartphone, for example, will talk NFC, and NFC is communication at centimeters distance, but it also talks LTE or 5G even for the new iPhones. And this is the wide area communication network. Which communication technique should be used for which application depends on the requirements for the application. If you want to get access in a building, NFC is perfect because you can wave your badge in front of an NFC reader and the door will open. But if you want to track people or to track objects in a building, Bluetooth is typically a better technique because you can have communication over 15 to 20 meters. If you want to follow a sensor in a building, then LoRaWAN is a better technique because LoRaWAN can go inside a complete building with only one gateway. So ask advice if you are not sure about which technique you need to use for your application, and Vitel is there to help you with choosing the right technique. There is a lot of, let's say, commotion in the market about long-range, low-power communication, like it's offered by LoRa, by Sigfox, but also by the new narrowband IoT network, which is a new kind of LTE communication that runs on the existing LTE cell towers. Why is narrowband IoT interesting? As you can see in the red circle, it has a very high coupling loss. That means that you can have a very low signal strength and still are able to communicate. And this is especially important if you are talking about applications which go deep inside a building. For example, in the basement of a building where you have a smart meter, you can still communicate with this smart meter using narrowband IoT, while this would not be possible with a normal LTE communication network. So that's why narrowband IoT is a very innovative new cellular communication technique that can be used for deep indoor use cases. But of course, in narrowband IoT, you need to have a SIM card per individual device, which makes it sometimes more expensive to deploy compared to a technique like LoRa, where you only need one SIM card for the gateway and all the sensors are communicating basically free of charge. So as you can see in LTE communication, there are two trends. You have a trend for more and more speed, and this is the trend that is followed by the smartphones, for example. The new smartphones are Cat19, which means they are 5G communication capable. This is, of course, very good for certain applications like video streaming. But in general, in IoT, they're not so much interested in this super high speed communication. They're more interested in low power and long range. So there's a split off since LTE Cat3 to go to Cat1, Cat-M1, and Cat-NB1 and B2, which are also LTE communication techniques, but going towards long range, low power, deep indoor penetration. So there's a different focus, not the focus on the high throughput and the high communication bandwidth. You've heard about Cat-M1, Cat-NB1, Cat-M2, Cat-NB2. What does this mean? This is basically an evolution of the low power long range communication over LTE networks. In the release 13, which is the current standard release, they have defined Cat-M1 and Cat-NB1 as two communication mechanisms, one with a very low communication bandwidth, the NB1, and one with slightly higher. This evolves into Cat-M2 and Cat-NB2 in the release 14, which is the newer LTE or 3GPP standard for communication. The CloudGate Nano, which will be explained by Melton, supports the release 13 communication methods, which is Cat-M1 and Cat-NB1. This was my introduction about IoT and IoE in general. So I give the word now back to Digit for the rest of the presentations.